Let's start by attempting to solve this problem with what we've covered in the previous two object-oriented programming lectures. The first attempt will be based on topics in the first OOP lecture, and the second attempt will be based on topics in the second OOP lecture. Okay, here's the first attempt. In this approach, we make circle, rectangle, and square classes that are all independent of each other. However, each one of these classes has a method called getArea. Then we make an array that's going to contain all three. Well, how can you make an array that you can put more than one type into? Answer, you use the parent type. Since circle, rectangle, and square are all implemented independently, what's the parent type? Answer, object. Remember that in Java, if you don't explicitly say extends, it's as if you had said extends object. All right, so it's perfectly legal to make an array of object, and it's perfectly legal to put circles, rectangles, and squares in that array because circles, rectangles, and squares are objects. Then we'll pass this array to a static method called SumAreas that we put in a utility class called perhaps shapes. All right, so far so good. Then in SumAreas, in that method, we define the parameter that we pass in as an array of object. Again, so far so good. But then we have something more dubious. We try to loop down that array and call the method that all three have in common on each one and add up the results. And we'll see that this will run into problems. So we define three classes entirely separately, but all three of the classes have a method with the same name, same argument signature. Then we make an array, and we declare the array the parent type, object. There's no other parent type in common of circle, rectangle, and square. And it's perfectly legal to put circles, rectangles, and squares inside an object array because circles, rectangles, and squares are objects. And then we're going to pass it to a static method defined in another class called shapes. All right, so far so good. But now we run into problems. We declare the array to be of type object, and we attempt to loop down that array and call getArea on each of the things in the array. This is a failure. This code will not even compile. Before I tell you why, stop for a minute and think about, pause the video if you need to, and think about why will this not compile? All right, you got your answer? The answer is that Java is strongly typed. And for Java to be able to call a method like getArea, Java has to know ahead of time, at compile time, that all of the things in the array have a getArea method. The problem is this is an entirely separate method. When I compile this code, Java has no idea what you're going to pass to it other than their objects. But not all objects have a getArea method. So this code will not compile, and it'll say object does not have a getArea method, and it'll fail. All right, so you say, okay, that's okay. I can handle this. I will use the topics in the second object-oriented programming lecture. In particular, I will use inheritance, and I will move the getArea method into the common ancestor class called, say, shape. Make up a name, and then I can guarantee ahead of time that all things that are subclasses of shapes have a method called getArea. So I make a class called shape, and I give it a method called getArea. But I don't know what kind of shape it is, so what should getArea return? Well, I don't know, but real shapes can never have a negative area. So let's plan ahead, and we'll make the getArea method of the shape class return -1. So that if we run some code and we ever see a negative value, we know that we've goofed someplace. All right, that sounds like a reasonable idea. And then we'll make circle, rectangle, and square directly or indirectly extend shape. But then each of those will have a more specific definition of getArea. We'll override the definition of getArea. And for circles, it'll be pi r squared. And for rectangles, it'll be length times width. For squares, it'll be the width times the width, or something like that. So each of them will extend shape, but they'll give a more specific definition of getArea. Then we'll define our array not to be of type object, be of type shape. We'll pass it to the static method as we did before. we'll have the static method declare the incoming array as shape array. And now it'll be safe to loop down that array and call getArea on each element because Java knows ahead of time that all shapes have a getArea. All right, so I start off with a parent class called shape, and I put the getArea method in the parent class. So Java will know all classes that extend shape have getArea. Subclasses can add new methods, but subclasses can't take away methods of the parent class. All right, and then I will say that circle extends shape. I will say that rectangle extends shape. I will say that square extends rectangle, which means that it automatically indirectly extends shape. So all three of square, circle, and rectangle directly or indirectly extend shape. I will make a shape array, but the things that I will put in it are more specific types. I will pass it to my static method, SumArea. I will declare SumArea to take an array of shapes. And now it's perfectly legal to loop down it and call getArea because Java knows ahead of time that all shapes have a method called getArea. Okay, this is a good approach. And if you're relatively new to object-oriented programming and you thought of this idea, then hooray for you. This is a good idea. And it does, in fact, let you make a method that's reusable, and it even accommodates the flexibility of future shapes. If sometime in the future I make another subclass of shape called ellipse or called a parallelogram or called triangle or something like that, and it has a getArea method, this code will still work. And I can make an array of circles, rectangles, squares, and ellipses and pass them to this method. All right, so this is not a bad idea, but it could be better. There are two small deficiencies, not terrible deficiencies, not fatal deficiencies. We'll compile and this will work, but there are two small deficiencies with this approach. See if you can think of what they might be. They're much less subtle than in the previous example. All right, pause the video if you need to think about it for a while, and then come back and I'll tell you the answer. All right, so there are two problems. The first problem is that shape is a normal class. So it would be perfectly legal to call new on the shape class. Shape s equals new shape. Well, but what's a shape? This is not like something in real life. It's just kind of the name of the category. The only reason we made a shape class is to make our code organized better. It wasn't kind of a real thing that we were looking at. It's kind of an abstract concept. And since shape is a normal class, you're allowed to call new on it, and you kind of want to prevent that. So you want to be able to say that the array is of type shape, but you don't want to be able to say that any individual objects are directly of type shape, only indirectly of type shape. That's the first point. The second point is that although in our code we had circle extend shape and then give a more specific definition of getArea, like pi r squared, it would have been possible to forget. Our code would have compiled if we said public class circle extends shape and we forgot to give a definition of getArea. Well, if we forgot to give a definition of getArea, then the getArea of a circle is -1. And the only way you can see that is at runtime. And a general programming principle is compile time errors are good, runtime errors are bad. Because compile time errors you find out about right away, runtime errors you don't find out until later, and sometimes you miss them. All right, so this is a good idea, and it's a good try. And it's not bad, but there are two small problems. One, you can instantiate shape directly, and two, it's possible to make a subclass of shape and forget to give a more specific definition of getArea. So we'd like to do even better, but to do even better, we're going to have to introduce some new object-oriented programming concepts.